Good evening, everyone. Doing this talk, it's maybe the second or third time I've done it. How's that? A little better? Okay. Every time I talk about Jupiter, I'm sorry to say, it brings me back nearly something on the order of almost 60 years. Because it was back then, I was just this side of 10 years old, that I was growing up in Gothenburg, New Jersey, the world's smallest 4 by 8 block town in New Jersey. And one of the bright objects in the sky, I believe it was that August, was a bright white object. It was Jupiter. See, they say the ancients discovered many of the older inner planets, 6 planets and such. Actually, I discovered Jupiter to my incredible delight. I was able to confirm what Galileo had seen many years before, of course, before of 95 now, known satellites around it. I got hooked. I already was into science in general, but that got me locked in here. So I'm rather happy to talk about this huge object in our solar system. And it's visible tonight. If we were able to free the domes over here, you'd be able to use the telescopes, particularly the 10-inch, which is more of a planetary instrument than anything else.
You don't like to see the keyboard.
Clearance technical difficulty, please stand by.
No, we don't need that.
You got it?
It needs to clip on the, there we
Yeah,
go.
we got it. Thank you. Okay. That was too bright. Okay. All right. So we are going to take a tour of Jupiter. It's a shame too, because it is a clear night, steady, maybe, but it is an object of view. Like I said, I've been observing it since 1964 on a regular basis. So let's get started over here. Just an overview. The planet is huge, 88,700 miles around the equator. It's 11 times the diameter of the Earth, twice the mass of all the planets combined. Or if you had a bunch of Earths you could put on one side of a scale and put Jupiter on the other side, you need 318 Earths to compare to it. If you weigh 100 pounds here on Earth, you weigh amazingly only 254 on Jupiter. That's because its composition is mostly gases, hydrogen, helium, as I mentioned down here, methane, water, ammonia. There is a rocky core in the dead center, surrounded by a layer of liquid metallic hydrogen, which conducts electricity, and it helps generate an incredibly powerful magnetic field up there. Composition basically is similar to what the solar nebula was that all the planets condensed out of. Okay, the cloud tops average about minus 244 degrees Fahrenheit. Very cold. After all, you are out almost a 500 million miles out from the sun. Its rotation, though, is astonishing. 9 hours, 56 minutes rotation on a 12 Earth year orbit. So if you're into astrology, it spends about a full Earth year in every sign of the zodiac. Okay, makes good calendar that way. We've had flybys initially, Pioneers 10 and 11, Voyagers 1 and 2, the Ulysses, Cassini, and New Horizons spacecraft. The cool thing about having this big, massive planet here is that you can bounce something off it gravitationally, save a lot of fuel, maybe put that weight saved into instrumentation, and you can move all over the solar system. There are orbiters currently, Galileo and Juno at present. Okay. Give an idea of relative size. This is, of course, Jupiter. This is something we're going to talk about in a few minutes. This is the Great Red Spot. It's a massive hurricane, easily twice the size of our full little Earth over there. And on this scale, 88,700 miles, 700 miles in diameter across the equator, Earth would make a terrific moon. I don't think any life would survive out there. We have a nice magnetic field, but we'd be shielded here. Fortunately, though, usually magnetic fields collect a lot of radiation, so I would want to ask if the life could survive there. And our moon is about the size, maybe an average, larger Galilean moon. Make a good one. We'll talk about that in a minute. Okay. Now, I'm sorry, folks, but you're all a little late. Jupiter hit what's called opposition directly behind Earth relative to the sun on January 10th this year. Fully lit by the sun is seen from Earth and visible, of course, all night. It still is. I mean, you look at the moon tonight. See where the moon is? There's a bright white star. That's Jupiter. It had a diameter at that time of 47.5 arc seconds, magnitude of minus 2.7, which is why it's so bright. It's in the constellation, according to astrology, in the constellation of Gemini at a distance from Earth at that time of 388 million miles, not too far to walk. It's almost overhead by 10 p.m. Matter of fact, if you look tonight, you'll be able to confirm that. But even a pair of binoculars on a tripod can see the 4 Galilean moons, and a telescope with 3-inch aperture and larger will see detail in the cloud belts. Okay. So when I mention about opposition and such, these are terminologies borrowed from astrology. However, it gives an idea of what's happening. When I mention a planet being in opposition, it means it's superior, one that orbits outside the orbit. And opposition, when it's lined up pretty much directly with the sun relative to Earth. Conjunction is the opposite number, where it goes behind the sun. We can't see it for a couple of weeks. Earth's orbit here, our planet orbit over here. Yeah. Now, because it is of its composition, there's no real solid surface underneath the pod deck. This gets denser and denser until it starts compressing down to the point that the hydrogen becomes solid.
Could you put the microphone closer to your mouth?
Treat it like a toothbrush.
Okay.
How's that?
Yes.
All right.
Hey,
I'll use my Darth Vader voice. Okay, yeah. All right. Well, anyway, because it's mostly cloud, it's mostly gases and such, what you're seeing over here are actually chemicals of organic composition. We have storms on Jupiter. The most notable one, of course, is the Great Red Spot, as it's called. It's at least 300 years old, 3 times the size of the Earth. That's actually shrinking a little bit. At one point, it was 5 times. The winds can kick up to about 400 kilometers an hour. And the Red Spot Junior has been sighted here relative to the Great Red Spot's position. And it's been moving about. We may have a replacement for it. I don't know. Because it has been shrinking over the past century and stuff. It just shows how it changes over a period of years. Okay. But looking at the night side, we start seeing some other phenomena. It turns out the outer atmosphere, we have thunderstorms. Imagine a thunderstorm half the size of the moon. This is what we're talking about over here. And we can see it because of the light that's generated there. Actually, I'm sorry. Is that bad that you're gonna leap it? Well, Yes, right.
okay.
Never in my life. Yeah.
Okay. And not to mention the fact that we have also the discovery. It was suspected for a long time, but there just weren't enough good observations from here from Earth. On March 4th, 1979, the Voyager 1 spacecraft from NASA took the first photos of the rings around Jupiter. Basically passed behind. This is the atmosphere. It's not that big. It's all the light can be blocked until you go down about 300 miles below the cloud tops. There's the ring. It was the first time anyone had seen them. And since Voyager 1 first had seen them, other spacecraft like Galileo and Juno continued to study. And it's believed that they form by comets colliding Jupiter's moons with dust orbiting the planet. At least that's what we think. We've never had any vehicle that can go up there and take a sample and either analyze it on board the vehicle or bring it to Earth for analysis. That will change someday. And yet, because Jupiter's magnetic field is 20,000 times the strength of that here on Earth, so it's constantly exhibiting displays of northern lights, southern lights, aurora from the charged particles of the solar wind.
This is a composite, of course. This is a normal white light photograph, and in ultraviolet, you see that raw activity. It's a bit of a close-up on it.
So it's a lot of interactions going on over there. Okay. Its magnetic field extends dramatically away from the planet. The planet is only 88,000 miles in diameter, but the massive part of the magnetic field is as much as half a million miles top to bottom. So this is incredibly powerful. It also has a magneto-tail that extends out. We don't know how far. It may go clear out to Saturn, which is another quarter million miles. Pardon me, a quarter billion miles away. Okay. And in 1994, I remember standing, not here, it was on the other side of this, but pretty much then to see a thing that had never been seen, we believe, before, where an object or objects crashed into Jupiter. Comet Shoemaker-Levy 9 was only one of many small objects over time was diverted from hitting the planet in the inner solar system. So this is one impact scar. This goes to show you how big some of the pieces that came from Comet Shoemaker-Levy 9, when it came close to Jupiter, was fragmented by the gravity and then came in many pieces. The deck died. This is a star larger than the Earth. Imagine if something that big had hit Earth. The actual comet piece itself was only about 50 miles across. But look how much damage it did. Okay. Moving back out, we call the largest of Jupiter's moons, now known so far, to be 95. Galileo in 1610, over a period, actually a few months, discovered 4 large moons of Jupiter. They're very small ones around. It probably captured asteroids and such, but these are the primary guys, the Galilean moons of Jupiter. And if you got a nice little telescope, or you have a pair of binoculars and you either hold them very, very steady, not exactly easy when you're shivering in the cold in the winter, but put them on a tripod and you will be able to watch these 4 shift back and forth. We're going to talk about each one in its turn. Okay, interior matters. Our moon is solid rock. It has a core which may or may not be warm, not hot. Mantle, and of course the crust, the outer surface is what we see as the surface of the moon. With Io, Europa, Ganymede, and Callisto, we're quite a variation. From our best observations so far, Callisto appears to just be mixed rock and ice, water ice, other materials, even into the core. Ganymede, apparently, we're going to talk about this guy here, because it's got a bit of a magnetic mystery, but it has a magnetic field. Europa, it's believed, has an under ice ocean. We'll talk about that later, as well as the south core. And Io is volcanically out of its mind. There's constantly activity going. Volcanoes all over the place. And no wonder it's closest one into Jupiter, and its gravity is literally, Jupiter's gravity is it's trying to pull Io in. Io accelerates. Something's got to give, and it melts the core. And we have volcanoes all over the place, but we'll get to that in a minute.
Al, is it tidal forces within the planet itself, the closer part being pulled more strongly than the outer one further away?
Yeah, it is because of the proximity. The one surface is a whole 1,000 miles closer to Jupiter, but it's enough because Jupiter's trying to pull it in. That action ends up as heat. The next thing you know, you got volcanoes all over the place. Now, speaking of Io, there's Io. The first time they saw a photograph of this, one of the technicians had stated, "Hey, that looks like the pizza I had last night." And it's hot as a pizza, but not exactly edible. We're looking at over here in the yellow, yeah, that's right. In the yellow, it's mostly sulfur. The other chemicals over here in the surface and reacting with the radiation from
the massive magnetic field around us from Jupiter, changed it, changed it chemically so that it's created other compounds and such as well. Hence the different colors. And another anecdote, when they first showed this to another one of the technicians, first time out, said that satellite's on acid.
Maybe they're right. Okay.
Here's a close-up to give you an idea of how big we're talking about. 50 kilometers roughly is about 34 miles. This is a lava flow. Here, what looks like a lava lake. And there are different compounds in here, mostly sulfur and sulfur derivatives. Volcanic activity. And it shows this series of photos, Zamama and Prometheus volcanoes as they're catching them in action, if you will. You can see the blue there is from chemical temperature interactions. It's a wider field of view. It does indeed look like a very ill pizza right there, say, but it's amazing. And the whole idea is how volcanically active is this? So I put you on oil right now in the proper shielding and such, and they gave you a laser pistol and said, hey, carve your initials on a rock. You find a nice big flat rock. And you carve your initials on it, you put a date with it. And then we go back into the ship, decontaminate, get some sleep, resuit up, go back down to the very same spot. This is how active this is. In that 1 24-hour to us period of time, whatever you put on and whatever you wrote has now been covered by lava. This is constantly in action. And this is Prometheus caldera that was referred in the picture before. Prometheus, you can see they caught the activity on the edge, close up. And then when it turned toward the sunlight, you're able to see the lava flow. It's fresh, not there the day before. Okay. Now I mentioned about the magnetic field, and you can see this looking rendition of just how extensive Jupiter's magnetic field goes clear out at least out to the outermost point. In this case, of Ballista. But look where poor Io is, right in the thick of things. So there appears to be a magnetic interaction, a torus, that surrounds. It originates rather in Jupiter and surrounds out all the way out 90 degrees plane of Jupiter's axis to Io. Okay, next one out is Europa. Actually, this is one of my favorite ones of the four giant moons. It theoretically has an ocean of water, as in water, drinking type sea or seawater. I'm not quite sure yet. But we're seeing lots of cracks and crevices here, and only a very few craters. That means that the surface here is constantly being renewed. All right. And you can actually see something like this occasionally. You'll watch Europa and the other the other three Galilean satellites pass in front or transit in front of Jupiter from our line of sight. And if you're lucky, everything works out right geometrically. Here you have Europa, here you have the shadow. You can actually watch them as they transit across. Oh yeah, this is a good close-up on the great red spot. Massive cyclonic activity here. And one of, I believe they still have three, these white ovals. And all of these are very, very large hurricanes and hurricane-like storms. Okay. Now, we're hoping to get a spacecraft out there. In fact, we're going to talk about one in a moment or two. A little bit of a preview of that. Using different radio frequencies, we should be able to not just detect oceans underneath the icy surface of Europa, we should, in theory, be able to see if there's an ocean down there and how far it extends. It may go only about a mile, it may go much further. Right now, we just don't know. Okay, and under the ice, I mean, I love this picture over here. It's a great artist's conception. An ocean below the ice, Now, here on Earth, we have black smokers in the deep ocean. And wherever we find them, there's volcanic activity under a mile or two or more of ocean water. We may have them, and we may also have what we have here, life. Good possibility of it. With this liquid water, with its chemical actions. Organic chemistry says there should be something either living or the precursors to something. And we do have evidence that this is happening here because we can see where there are breakouts all across the open surface. Even some of these lines here, where they break like this, some material comes up and they separate away from it. So who knows? We may have something there. I'd have to get a refrigerated tank for it, but I'd love to get a European fish from there. You know, the ones with 3 eyes and the 4 tentacles. So we'll see. We'll see what happens. Actually, it's 5 tentacles. Okay. Possible upwelling is one of the best examples of it. Yes, we have these here. Some material forms up, and we have this big guy over here. So something underneath here disrupted the ice. Coming up with this would be great if they had an orbiter out there that would be able to look at it and watch it as it develops. Okay, next one out is Callisto, mostly made of ice and rock, but without a real core as far as we can tell. The craters look mushy, not really eroded, just from the sheer weight. Even that light gravity over hundreds, tens of thousands of years, it would just kind of bend. Strong new evidence for a salty ocean underneath an ice crust. It's as large as around Ganymede, but dark and very heavily cratered, you can see here. And it's interesting because there's an impact structure called Valhalla, great name. And on the other side of that impact, we're seeing this structure, the antipodes, called, and all these craters pop up, not from above. So it's wild stuff. Nice to be able to get some kind of a lander on there. Always great to have a lander, preferably a rover. Okay. And Ganymede, which is currently the largest known moon in the solar system, it's bigger than Mercury. Mercury is about 3,100 miles in diameter. Has a very strange magnetic field. We'll talk about that in a moment. Some of the older regions that are seen here, some of these large patches, maybe about 4 billion years old, dating to the creation of the solar system, maybe even the object itself. Apparently, there is plate tectonics. Plates are not made of rock like here on Earth, they're made of ice. And it seems to have a salty ocean underneath the ice. And I mean, I love some of these things. Our moon relative to Ganymede, Mercury, Ganymede's larger. But here's the kicker. Different forms normally done under compression and extreme cold temperature. Ice 1, 2, 3, and 4. There's no 2 here that I see. But 3, 5, and 6. Different crystal structures. Normally, it's only in a laboratory. Here, it's right out on the surface. And here's the real kicker. On Earth, and for that matter, every planet we've seen so far, you have a North Pole, a South Magnetic Pole, and force lines that connect them. Ganymede's weird. It has a dual magnetic field. Now, I'm wondering if maybe that might be instrumental error. One of our vehicles one time get out there and be able to examine it in closer detail. But so far, this is what we seem to be seeing.
What does it mean that there are 2?
In other words, there are 2, seems to be, 2 north and 2 south poles. The dual magnetic field. How? I don't know. Neither does NASA at the moment. That's why we need the fact we have probes that are out there that are operational right now. Maybe they can get a good close look at it. You don't know.
So the magnetic fields will interfere with each other.
It should,
Yeah.
but they'll tell Ganymede that.
Right.
We'll get more information. We'll find out. I hope. Okay, and it's on. Speaking of, it's on its way. This is NASA's Europa Clipper. It was launched in 2024, October 14th. It's going to reach Jupiter's space by 2030, and it's going to fly by Europa. It pretty much is going to study that in very great detail, because again, with this life, there might be a way of being able to detect it. And it'll also do other probes too, but it's dedicated more toward
looking at Europa, looking for water and the potential of an ocean, maybe even life. Who knows? When it gets there, we'll hopefully find out. In April 2030, this is going into orbit around, of course, in Europa. So with all the cracks and crevices, it's ice, even outwelling somewhere. So there may be something there. Maybe there's a European frozen fish waiting for us to get it. And it has the largest solar panels that any vehicle has had to date. They measure 100 by 58 feet. Yeah, I agree. But that 100 feet, to give you an idea of scale, Sperry Observatory, tip to tip, is 85 feet. Front to back, it's only about 32 feet. So these are huge solar panels. This is to, one, avoid having nuclear materials on board, nuclear batteries, if you will, because any background radiation is going to be interfered with, and we won't get a clear idea of what's happening with magnetic fields. It's the reason why we did it this way. At least that's how I understand it. These are the largest panels yet flown on any spacecraft. Okay, and the radiation danger ahead. It's going to plan to have 49 orbits. Europa Clipper will be exposed to enough radiation to absorb the equal of several million chest X-rays per flyby. Laughingly, I've heard one of the astronomers state that you could take a piece of lead and watch it convert to gold from all the hard radiation. You got a good laugh out of it too. I'm not laughing. I don't think anyone's going to be able to actually walk. A human will walk on Europa unless it has some technology we don't have today. So for the future, as soon as somebody demonstrates the art of flying, settlers for our species of man will not be lacking on the moon and Jupiter, given ships or sails adapted to the breezes of heaven. There will be those who will not shrink from even that vast expanse. Johannes Kepler. Not bad. He's right. I love this. I had to put this in. The first real Cassini image that brought tears to my eyes, because Cassini was sent past Jupiter to get out to Saturn, was an image of Jupiter. I didn't expect it to look so detailed. That's Carolyn Porcup. Wonderful technician, wonderful professor of planetary astronomy. And then I'm going to give you folks a good look ahead. Tonight, when you go leave the observatory, look up at the moon, and you're going to see there's a bright white star. That is Jupiter. It's not a star. You have a pair of binoculars, you might be able to see close in several, maybe all four of its moons tonight. And the moon much closer in, of course. But it's jumping a little less than a year ahead. Jupiter and Mars, Jupiter here, Mars here, will be in the constellation of Leo, and right next to it, Gemini, which is where currently where Jupiter is, on January 10th, 2027, at about 11 p.m. Eastern Standard Time. You will see Jupiter and you will see Mars. And Mars will be approaching an opposition, or in other words, if you remember that chart before, I didn't mention it. When a planet, a superior planet, one that's beyond the Earth's orbit, comes into opposition to the Earth, it is at its closest and brightest, usually. And Mars is going to be especially close on that date, very close to its opposition date, 19 days after this date, which is opposition to Jupiter. So you got something to look forward to. But then again, every night you look up at the sky, and it's clear, and you got lots to see. Oh, yeah. It would just pass that date. But it had to be noted. And what I said years ago, I said this some years ago, that's true, that to not explore brings us only one place, back to the caves. And I, for one, don't like living in a cave. How about you? All right, I got a bunch of explorers here. Good. God bless. So when your telescope doesn't work, your camera freezes up, you are turning blue from the cold, Just remember this. The matter is you don't just give up. So I have to thank various people here, my wife, of course, Connie, who actually made sure all these things are proper and straight and gets the spelling right. Melinda Callis, very dear friend. Mary Duca, Cliff Ashcraft. Hey, Cliff, how you doing? Jim Nordhausen, and all our associate qualified senior and field observers that are here at AAI and composition.
So for those of you who are here,
I was asked how notice that the core is iron. So much of it is hydrogen. Magnetic field does tell us something about it. It probably has a magnetic a core of iron, nickel, and other materials, maybe about the size of the Earth. And then things just gathered up and gathered up. Next thing you know, you've got a planet the size of Jupiter, or even bigger. Any other questions?
Al?
Thank you very much for the presentation. I some time ago I read about people in the 19th century and possibly even early 20th century discussed or put forth the notion that there were other human societies on other planets. Do you have any interesting sort of historical remarks there or knowledge of, say, outrageous theories that have existed over time about Jupiter?
Say super giant person or a little guy from Jupiter who is alone 4 to 5 people. This thing has pretty much ignored a lot of the gas giants unless it's like a place to set up some other thing on a moon and they have a shootout or something. But that's about it, really. Most science fiction stays right here. Usually the aliens come here. So, which is very nice of them, usually.
Well, I think you had a question.
Okay. We have a question from the internet.
That would be me, I think, Al.
Okay.
Is one of the other reasons that they don't want to use a nuclear battery on the Clipper because the ultimate fate is to crash it into the satellite, into the moon, and they want to pollute it as little as possible?
It's possible. I would think so. Although
Yeah.
I've heard plans for Juno to do a suicide run into the atmosphere of Jupiter to burn it up, which is ridiculous. I'd much rather take a spacecraft that's just about ready to shut down, bounce it off Jupiter's gravity, and throw it into a much higher orbit so that a museum like the Smithsonian can finally get the darn things. Yeah, they've been bombarded and highly radioactive, but the technology that would allow us to do that also would allow us to be able to, essentially decontaminate it, or at least put it into a place that we can see it and study it. I'd love to see what happens to aluminum, for example, after about 4 centuries of particle bombardment. It would tell us a lot, I think, of chemistry.
It would be very interesting indeed.
Darn straight.